One of your assignments for Unit 7 was to study the NUMI case study. And of course, the way that Toyota works is justly very famous, to the extent that many people have studied Toyota and their factories and the way they work. One of these people is Mike Rother, who wrote a book called Learning to See, which is all about value stream mapping. He's been studying Toyota for a really long time, and companies would hire him to teach them about what Toyota did so that they could try and emulate Toyota. Now, something interesting would happen. Mike Rother would go back to the factories that he'd visited before and see that those things that he'd told other companies that Toyota did, they weren't doing anymore. And of course, that was a bit mysterious and weird. And he came to understand that what was critical about Toyota was not the particular things that it was doing at any one time. It was Toyota's ability to problem solve and come up with new ideas to address the challenges that they were having right now in pursuit of the particular goals that they were trying to achieve at that time. Their problem solving ability and the ability of their people to solve problems, not the particular solutions that they came up with. He wrote up what he discovered about Toyota's method of management and problem solving in this book, Toyota Kata, which is well worth reading. But I'm going to give you another case study which shows you how to apply this in the domain of technology. We've talked about HP LaserJet firmware, the future smart product, when we talked about release planning. Now I'm going to do a bit more of a deep dive into this case study and what happened. So HP LaserJet's firmware division was a 400-person team distributed across 3 different offices, one in Porto Alegre in Brazil, one in Boise, Idaho, and a third one in Bangalore in India, now called Bengaluru. In 2008, they had a problem, which was they were going really slowly. They were unable to deliver their new products on schedule because firmware was always on the critical path. And this carried on for several years, in fact. And eventually, the product people were so desperate and frustrated that they turned to the technical leadership for help, which is how you know things are really bad in product. And what the technical leadership did was interesting. They didn't try the usual approaches of firing people or outsourcing people or the kind of things that management schools tend to recommend. What they did is they looked at what people were doing using a practice called activity accounting. In activity accounting, we look at how teams are spending their money in terms of not the things that they're spending money on, but the activities they're spending money on. So cost accounting, traditionally, you count all the things and you see what's expensive and what's cheap, and you try and reduce the number of expensive things. And in software delivery, the expensive things are the people. So what happens is you try and fire people or reduce headcount. In activity accounting, you look at what people are spending their money on in terms of activities. And they did a low precision study to look at what people were spending their time on. Here's what they found. 10% of the team's time was spent on code integration, getting code integrated into a common code base. 20% of the team's time was spent supporting the detailed planning process. And what would happen here was the product people would put a big list of all the things they wanted to achieve in their roadmap over the next year. And the technical people would go and break this down and do very detailed estimation of the kind that we've discussed and say, well, this is completely unachievable. Choose the top 2 things from your list and we'll try and do those. And they'd get about 6 months into the plan and realize that even that was impossible. And the product people would get super upset and ask them to do a detailed replan. And all this planning work was consuming 20% of the team's time and budget. And this is basically a symptom of a breakdown of trust between the product team and the technical team. They used a technique called branching in version control to manage the differences between different products. Every time they brought a new HP LaserJet product out, what they would basically do is make a copy of the source code for the firmware. This is called a branch in version control. Anytime they wanted to make a fix that impacted more than one product or a feature that would be used on more than one product, they had to copy the code across the code base for the different devices and merge it, which is a very time-consuming activity. It took 25% of the engineering budget to do that. 25% of the engineering budget was spent on product support. What is product support engineering time a nice proxy variable for? Well, the answer is quality. If the team is spending 25% of their engineering time on product support, that tells you we have a quality problem. They were spending 15% of their budget on manual testing, and if you subtract this from 100%, what you're left with is 5% of the budget and activity spent on actually building products. This is really fascinating and quite common. What you will see often in large organizations particularly, but frankly every kind of organization, is the engineers want to spend time on things like test automation and refactoring and good design. And a lot of the time, the product people will say, well, listen, we don't have time for that because look at all these features we have to build. And what you can see immediately from this is, well, the reason that we are having to move so slowly is because of all this non-value add work that we're doing, which is taking away our capacity to actually build features. So unless you fix this, unless you find ways to decrease the amount of non-value add work you're doing, you're going to continue moving more and more slowly. What you need to do is remove this wasteful activity to increase the amount of capacity the team has for working on building features. The other thing they looked at is cycle times. It was taking a week to get code committed into Trunk after the code had been written. They were able to produce 1 or 2 good builds of the software, the firmware, every day out of version control. And it was taking them 6 weeks to do a full manual regression to test the software before it could be released to manufacturing. What the FutureSmart team decided to do to address this large amount of waste is something actually quite risky, which is to completely re-architect the firmware from scratch. They had some key goals for this re-architecture, which were designed to address the waste in their delivery process. First of all, they wanted to reduce hardware variation. The fact that hardware varied significantly between devices was the reason why they had to make these copies in version control. And so they worked with the hardware people to build a single platform for every product they launched so that they could build a single code base which would work on all the different devices. And that substantially reduced the amount of work porting code between branches in version control. And instead of using all these different branches, they could use one single unified code base to target all the products that were built in the LaserJet line. Because they had a single package, they could practice continuous integration, which is where they're regularly checking all new work into a single main line or trunk on version control instead of all these different branches. However, they ran into a problem, which was that it was taking a really long time to test changes. So they implemented a comprehensive test automation suite in order to validate new changes and make sure they weren't breaking anything and that they worked as intended. Now, the firmware ran on custom fabricated chips. So you couldn't just run the tests on your local workstation because it's running on a different CPU. So what they did is they built a software simulator for the custom logic in the printer so that they could run the tests on the simulator on their local workstations. So building this simulator for the hardware platform was a really substantial engineering effort, but what it meant is that developers could test their code on their local workstations and get very quick feedback on the impact of the changes they were making. All this work allowed them to change their whole delivery process and make it much more efficient, which meant they were able to deliver features much faster. But it did take them 2.5 years to achieve that, so it was a pretty long time. But let's look at the impacts on those key metrics we discussed. So from 2008 to 2011, code integration goes down from 10% of engineering budget to 2%. Instead of a very detailed planning exercise where they broke everything down into tiny bits and estimated it, they moved to a much higher level, low precision planning process, which we discussed in the unit on release planning. And that requires much less engineering effort. So engineering effort goes from 20% down to 5%. Because they're not working all these different branches, instead of spending 25% of their engineering budget on porting code, they spend 15% of engineering budget working on this one main branch. Product support goes down from 25% of the engineering budget to 10% of the engineering budget. So that means a substantial improvement in quality. Testing goes down from 15% to 5%. And finally, innovation goes from 5% of engineering budget up to 40% of engineering budget. So there's a 8x improvement in developer productivity measured in terms of resources spent on building features. So that's a nice way to think about team productivity. It's also a really substantial improvement. Now, if you're paying attention, you'll notice that there's something wrong with the numbers on the right-hand side of this slide. They do not add up to 100%. And that's because there is a new activity that's happening. That is 23% of the engineering budget is being spent on managing the automated tests. That seems like a really high amount. If you had a team that wasn't doing automated testing and you said to that team's management, hey, we could really improve productivity by investing 23% of our budget in test automation, you would probably get laughed at. And yet what we find here is by spending substantial amounts of engineering budget on creating and maintaining and managing automated tests, we're able to substantially reduce waste and end up with an 8x improvement in engineering productivity, which is massive. So this is one of the common misunderstandings about lean thinking. Lean thinking talks about removing waste. By removing waste, people often think we mean cutting costs. That's not what we're doing. We might have to spend more money and invest substantially in order to do things like test automation to remove waste in our delivery process, which in turn leads to substantially improved productivity. And that's what you see in this case study. And the nice thing about this case study is we can see the economic outcomes. Overall development costs end up being reduced by 40%. Programs under development are increased by 140%. Development costs per program are down by 78%. And resources driving innovation are increased by 8x. So, you may ask, what amazing methodology did the LaserJet firmware team implement? Did they implement SAFe or Scrum? Well, no, they didn't do any of those things. I mean, SAFe wasn't invented at this time. And in fact, the continuous delivery book was not out at the time they wrote this. They invented these ideas themselves. And the way they did it was setting a true north vision, which was firstly getting firmware off the critical path for new product launches, and secondly a 10x improvement in developer productivity measured in terms of engineering budget spent on building new features. And then they left it up to the teams to work out how to achieve that. So this is crucial, setting a true north of objectives that are measurable and clear, and then delegating implementation down to the teams. And this is the same pattern that Mike Rother found Toyota used to drive their improvement work. He calls this model the improvement kata. Now, it's often the case when we're talking about lean thinking, people like to use Japanese words because Toyota and Honda, Japanese companies. Let's talk about what a kata is. A kata is something that you practice over and over again so it becomes a routine. And the common example of this is martial arts. When you study a martial art, you learn forms, which are basic movements that you repeat over and over again so that you learn them. But we also use kata in many other fields. For example, if you play music, you'll practice your scales over and over again. Those are forms for music. They're basic building blocks that you practice until they become routine, that you do them with your muscle memory, and then those become the building blocks for higher level creative activities. When you learn to cook, you learn basic techniques like how to chop things properly, different combinations of spices to use in your cooking, and then once you've mastered those become building blocks for higher level creative activity. So it's very common when you're learning any new skill, you'll learn the building blocks, you'll practice them over and over again until they become habitual, and then you'll use them as building blocks. So the idea here is that improvement work the kind of everyday work we do to improve our organizations and our team's ability to get work done becomes habitual. We make improvement work a habitual practice within the organization. And here's the Toyota Kata improvement kata model of doing that. First of all, we're going to create a challenge or a direction, a true north if you like. And in the case of the Future Smart case study, the challenge or direction was the 10x improvement in engineering productivity and getting firmware off the critical path. Then we grasp the current condition. What's the current condition right now? And this is what the Future Smart team did by a combination of looking at activity accounting and also looking at cycle times. So that is the current condition. And then you set a target condition for about 1 month from now. And the target conditions we looked at earlier in our unit on release planning, these are OKRs basically. So these target conditions that we looked at previously, they are ranked, they have acceptance criteria, we know what good looks like, but crucially, we don't talk about how those target conditions will be achieved. That is up to the team to work out how to do that. And this team created new target conditions, new OKRs every month, and then left it up to the teams to work out how to implement them. And then the iterating towards the target condition is done by the individual teams. And then this cycle repeats every month. Every month we look at how we're doing, we establish a new set of target conditions, and then we delegate it to the teams to work out how to achieve those target conditions. So this is the Toyota Kata way of implementing improvement work, which drives up productivity and quality and reduces costs. And it's achieved by setting clear objectives and then having the team run experiments to work out how to achieve those objectives using the scientific method. When I read the Toyota Kata, I was really excited because it was clear to me that the same practices that Mike Rother talked about for improvement work were the same practices that apply when you're adopting an experimental approach to product development. So you can use this same improvement kata style for product development, for organizational change, and for architectural change. This idea of setting a true north and then on a schedule, on a cadence, setting the outcomes you want, and then delegating to the teams how to actually adopt that. And Gary Groover is very clear. Teams were free to choose their own methodology. Some teams used Scrum, some teams used a more waterfall approach to doing their work. Teams were free to decide what methods to use. But what they shared is a focus on a common set of goals, which they were only able to achieve if they worked together. And that setting of goals at the division level, at the Future Smart level, and then leaving it up to teams to work out what work to do and how to work together and collaborate and how to do that work in order to achieve those goals, that was all delegated down to individual teams. So this is quite different from what you might hear about if you study different methods like Scrum or SAFe or LESS or any of the other methods. But it's important to point out that it's the problem-solving work that teams do that helps them improve. You can't just take what other people have done that's worked for them and then copy that stuff and expect to gain the same results. This is what the NUMMI case study teaches us. Every organization has a different current condition, a different set of goals, and a different context. So copying things that worked in one context and trying to use them in a different context in pursuit of different goals in a different situation is not effective. There's a story from Toyota's early days when they were actually building looms before they started building cars, where the plans to their latest product were stolen by a competitor. And somebody asked Kiichiro Toyoda, who was in charge of Toyota at the time, what he was going to do about the fact that these plans had been stolen. And here's what he said. He says, "Certainly the thieves may be able to follow the design plans and produce a loom, but we are modifying and improving our looms every day. So by the time the thieves have produced a loom from the plans they stole, we will have already advanced well beyond that point. And because they do not have the expertise gained from the failures it took to produce the original, they will waste a great deal more time than us as they move to improve their loom. We need not be concerned about what happens. We need only continue as always, making our improvements. And this is what defines high-performance teams. They are working on solving their own problems, making mistakes, learning, and that institutional process of experimenting and learning is what enables them to continually improve and get better, not looking at the competition or trying to copy things from the competition or from other companies, but adopting a rigorous, methodical approach to improvement work based on having a clearly defined direction, setting clear objectives in the medium term, and then delegating to teams how to experiment to achieve those objectives.